Hello, everyone. Thank you for coming. My name is Marek Puchalski, and I am going to speak about security today. Not just any kind of security, application security, so the art of making your application more resistant to the environments they will be running it, and sometimes those environments are kind of malicious, like the internet or so. So let's start with a few words about me. I am Marek. I work for Capgemini in Wrocław. I am kind of grateful. I think grateful is a good word because I'm allowed in my daily work to combine two things I love doing, like doing development and doing the work of a security engineer, security architect. Sometimes I do tasks of a security tester as well. And my company kind of tolerates or even supports me by giving tasks that kind of makes me write code in the morning and then go through different projects and evaluate security or work as a consultant. So this is kind of a mix of tasks, what I do, but it is also a mix of different mindsets. I mean, developers have usually this kind of a builder mindset. They kind of try to get their job done by putting as less effort as possible. And there are builders, there are defenders, there are also breakers, people with a mindset of kind of testing, evaluating if things work properly this way. So I kind of were looking around whether there are other people that are trying to mix those two mindsets in their daily life. I have found a handful of them, and not even in my company, but worldwide. If you do your work on this way, on your daily basis, please contact me. We can drink a beer and speak about it. Oh, and I am a NOAA's member as well, if it matters. What I am going to speak about today. I am going to speak about security. What is security? What is the purpose of security? What is the purpose of application security? I sometimes use this picture to kind of tell what security is and what security isn't. And in terms of falling from a height on the floor, well, security isn't about the art, how you fall on the ground. It's not about the problem of the last 5 centimeters before you hit the ground. It's not even a problem of being pushed or jumping from the cliff. What security is actually about managing risks. So in terms of falling, the risk is combined with a height from which you kind of will fall on the ground. So you usually want to keep the height low, but not on a ground level. There are certain risks you will be willing to accept, like, I don't know, jumping from the height of your feet. I could probably do something like a jump from 2 meters high, not every day, but once in a while I wouldn't mind, probably. So the frequency of how often you fall on the ground has also something to do with security, and it is something that you will want to optimize as well. How you respond to the risks if they materialize, if the threats materialize, is also a task of security, but it's not a task developers usually need to deal with, so we kind of will skip this part. Okay, why this talk about security? The talk about security kind of makes sense. It is one of many talks. You probably have heard some of them today or yesterday as well. It's because when you look at the numbers, when you look at the statistics, they are really, really bad. And those numbers, those statistics you see right now, they are from the last year. A year before, they were even worse than this. So imagine how they must have been a year before. What they are actually saying is something like, if you have a system, then actually it is quite sure that you have at least one critical vulnerability in the system. And critical vulnerabilities are jumps that are sometimes from 50 meters high. So someone usually dies when someone when the threat materializes and when the system gets attacked. So we do not want this. This talk is about a set of controls that is meant to prevent those falls. I treat this lecture as a kind of a baseline, meaning that you actually must at least think about any of those points that you will see on the slides. I mean, you can decide against it. Like I said, I mean, there will be an acceptable level of risk, but at least you should have thought at least once about every of the points, and there will be one point that will be kind of not a baseline, that will be kind of a future, and it will be about the universal second factor, because I think it's cool, and I think you might enjoy it as well. Okay. If you ask the people who is responsible for the poor state of security, penetration testers usually have an answer on this one. They claim that kind of the developers, who are the only people who write the code, they are responsible because, well, they are the only people who write the code. So if there are mistakes, security bugs in the code, then developers are the one responsible. I do not buy this one, probably because I am a developer as well, you might say. But I think what developers do, they kind of try to optimize. They kind of try to deliver. The things they deliver are the things that are required. So if security is not a requirement, it will not be delivered. This is the problem. The idea of this presentation was kind of to inspire the developers, because this is one of the most common questions I have been asked on conferences and in my company as well. So as a base to talk about security, I would like to present you this model of a system. And it might be the simplest model of your system you might have ever seen. All the beauty, all the ugliness of your code, all the complexity, all the databases, all the web servers, application servers, they are all hidden in this blue, wonderful square. What do you need to understand about this square to make it more secure? The first thing you need to understand is that it's actually not your code that is running there. It might be surprising. It might be confusing, but it is not your code. Well, it is your code to a certain degree, but to a small degree. I mean, if you look at this white paper, they say, the researchers say that 80% of what you think about your code is, your system is not your code. Those are open source libraries, those are servers that are running your code. I mean, just think about it. And this is a story that happened to me as well. I have created 2 years ago a Spring Boot app. And it was a small app because it kind of had only about 60 jar dependencies, as I have generated it on the website. So if you would create something bigger than I did, it was a small web application, not even Hibernate was there, you might land at about 100 dependencies and more. You have not written a single line of code, yet you have 100 dependencies to some libraries that do not belong to you. And what is the problem? What I did 2 years ago, I kind of have written the system, have checked the code in, and that was it. I mean, I forgot about it for about 2 years. And after 2 years, I was evaluating some applications for static code analysis that search for vulnerabilities in open source code. And what I have found out was actually this, that I had one critical vulnerability and a bunch of medium vulnerabilities. And I already know there is a false negative inside of it. There should be one library more as well. What bad can happen if you let known vulnerabilities into your code? And like you have seen, it can happen without you actually doing anything, yes? It's silly when you think about it. The code corrodes on its own because you're not maintaining it, you're not touching it. I have 2 examples of things that can happen. And this is Struts2, a vulnerability from this year. And look at this beauty. I mean, this is on a criticality level 10 out of 10. Can you see it? This code, this is an automated way to attack your system. So any American analphabet can use it to attack your system and to actually execute some kind of code on the server side. Look, the headers, here is content type, and then the payload is kind of big, but you can see back, no, but you can see the place where the command to be executed is to be injected. 10 out of 10. When you look on the vulnerabilities in Struts2 in 2016, there were 15 of them. I mean, as a developer, as an architect of a Struts2-based system, you kind of get used to quick updates because you do them actually at least once a month. Speaking about Spring Boot, this is a vulnerability, I think 2 years ago was it, and it is kind of still something like a server-side execution. You see here the multiplication that is passed as kind of an expression in a URL. And if the page, if the site did not override this white label error page, the standard error page, it was kind of the entry point to execute your code. You kind of can see on this side that 12 multiplied was by 12, that it was kind of executed. You would still need much more code to execute your own stuff, but this is the entry point. So such things can happen. What I still wanted to show you is that there are, in 2016, for the whole Spring platform, which is much, much bigger than Spring MVC, there were 6 known vulnerabilities. So you can kind of use the CVE dictionary to compare the libraries you might be wanting to use by just comparing how much trouble you can expect from them in the future. I mean, this is a cool metric. I don't know if you have thought about it. And what I have shown you right now are the worst kind of errors. I mean, you do not want that a person from outside gets to execute their own code on your server. This is really, really bad. But to understand this problem a bit better, it's not just about the frameworks, like Struts2, like Spring MVC. Even problems or security holes in Apache Commons can lead to an exploitation of your system. So it's not just the frameworks you need to care about, the other libraries you need to care about them as well. So how do you need to deal with this problem? Sam has already told today that you need to update, and this is one approach. You can go update everything as it appears, and there is a certain trouble involved with updating everything always. So there are some scanners that can help you with it, like the OWASP dependency check. I have told you I am an OWASP member, so I kind of promote some of the OWASP solution. This is open source, yes? You do not pay for it. This is the great thing about OWASP. And OWASP dependency check is surely not the best tool out there. There are some false positives, some negatives that you will see when you run the tool, but it is surely better than nothing. So this is a small thing. As a developer, you can kind of take this tool, scan your whole application with it, and see what you got. And in a year, at least one vulnerability will appear in your libraries. So if your code is 10 years old, so expect about 10 vulnerabilities to appear there. Okay, this was about the code. Let's build up on it and let's add some parts to it. Systems usually have a communication channel and there is some kind of a user agent. We usually call it a browser. Let's look at this communication channel. First thing is that we are in a 21st century. So we are kind of not allowed to not encrypt the transportation channel. Why is this? Well, Nick Waver said this way, that a traffic visible to an adversary is not just an information leak, but a vector they can use to attack. So what he kind of means with it is every time you access the ONET page, which is not encrypted, it is not just an information leak that everyone knows what you're reading, and in the network, kind of everyone knows you are probably right now in this local Wi-Fi network, so everyone can kind of spy on everyone. This is the rule. This is how the networks work. It's not an information leak. I mean, if you have access to the wire, you can inject everything. You can inject the attack vectors against your browser. So there are certain risks that should not be acceptable in the 21st century. And on the other side as well, I mean, if you control the server and the server communicates over an insecure channel, so every kind of write you pass to the user is a kind of a risk to the server, because you do not know who is listening to the channel, and the one listening to the channel can do everything. The purpose of TLS. I mean, you want to have TLS. It's not just about encryption, it's about confidentiality, integrity, and authenticity. So without using TLS, you are never sure which server you're talking to, because everyone can pretend to be the server. TLS is such a wonderful topic to speak on a conference. I mean, look at those buzzwords. Many of them, and behind every buzzwords there is math. So you can kind of create the best presentation nobody will understand, ever. The good thing is, as a developer, you do not need to go through this pain to protect your servers. In case you're doing a startup or just need to protect one of your resources, you can kind of configure TLS, and like Sam said today, you can kind of have the certificate for free. You can kind of have the certificate for free, you can configure the server, and the way to configure the server properly is to run some tests against it. I mean, you are all developers, so this TDD-like approach is kind of familiar. You run the tests against the server and kind of see the results. And one of the products, one of the pages you kind of can use to scan your system is this SSL labs. So every system that is exposed in the internet, just put SSL labs into Google, open the page. On the right side, you will have a link to that will kind of lead you to a page you will be able to start the scan with. And some of you have probably notebooks open, so you can kind of do it right now. You can run the test against your environment if it's public. And do not worry about it. If it is public, then the attackers have run this test before. So you will surely not be the first one to do it. And if your application is an intranet, you must kind of trick by using some scripts that run in a shell, or there is another product from OWASP Deep Violet. Those tools are free, and you will get a response within seconds. There is no reason not to do it. The attackers will do it. Okay, let's skip to the user agent. User agent acts on the client side, and we kind of sometimes in the marketing brochures of our system claim that we care about the security of a customer, and and we do different things to ensure the client is protected. So the question I usually ask at this point is, what kind of controls do you deploy on the client side to ensure the client is protected? The answer usually is TLS. Well, it's not a client-side protection. It is some kind of protection, and kind of we've been told that by the banking system that TLS is this kind of protection. It proves that the systems are secure, which we know is kind of false because we're developers. We know how the systems work. And so back to the controls you can deploy on the client. So what can they be? And one of the controls you might think about deploying are security headers. So just a reminder what security headers are. Here a definition by picture. The blue things are headers. And security headers are client-side controls that needs to be implemented on the server side. So they are kind of those response headers you see on the right side. Which headers are security relevant? Here is my list of the headers I think are security relevant. And I think this list could be even a bit bigger. One or two headers might be still missing. And the question for you is, have you thought about the configuration of each of them? My experience with a project is people usually don't. The bad thing about systems and the security headers is your system will work perfectly without them. The system will work perfectly without you needing to care about any of them. And this is a bad thing, because the proper configuration, the proper security configuration needs time. And it's kind of hard to convince people that you will be putting time in security if everything can work without it. Let's go through the headers one by one and think for a while why they are security relevant and how we can, what we can do with them. So first, header first, cache control. You actually should know this one. Why is it security relevant? Well, the users usually do not want their own data to remain in the browser after they log out. And this cache control, if the cache is turned on, the data will remain. So the next person who kind of accesses the browser, when they go back to the page, they might kind of see the sensitive user data that is revealed. So this is kind of a simple trick, and the attacker, to exploit this, would need kind of this physical access to the system. There is a simple solution to this, just turn off cache. If it's JavaScript, if it's pictures, publicly available data, it's okay to turn the cache on, then turn it off. And the good thing is it's Spring Security default. So if you're using Spring Security and the default header configuration, you will be safe at this point. Next header, HTTP strict transport security. What it does, it registers your domain, if it uses a valid certificate, as an STS domain in your browser. It actually means that the communication with your server will be performed only through a secure channel. So if you have, let's say, images on your page hosted by the same server, and you try to access them over an insecure channel over HTTP, I mean, this would kind of result in a mixed content, then the browser would try to redirect the whole communication over HTTPS, and if it would fail, it would do not download the pictures. This is kind of what it would do. And if you would consider deleting your certificate and going back to HTTP, it wouldn't be possible. I mean, your users would be kind of face a page stating that it's not possible to the usage of HTTP strict transport security, and they wouldn't be even able to ignore it. So there is a certain kind of risk involved with using this header. But like I said, in 21st century, we kind of should use this one. X-frame options. It's a header to mitigate the threat of clickjacking. What is the threat of clickjacking about? Look at this. Someone is going to attack you. And they kind of have sent you this page, free candy. I mean, seems legit. Would you click it? The slider above kind of reveals the magic of this attack. There is an iframe over the candy page, and this iframe contains the page that is going to be attacked by you. So, like you see, there is a button, and this button has not been clicked yet. So everything so far is fine. And a real attack page would not contain this slider. You know it. So what you would see, you would kind of see, okay, the first thing you see is I kind of suck with CSS. And the next thing you see that this button, get candy, is not really a candy button. It's a button on your page. Someone is trying to trick you into clicking this button. Simple attack. How can you mitigate this kind of threat? Oh, something bad happened. I don't know. You have deleted your social page, whatever account right now by clicking this button. Sorry, such things happen. So how can you mitigate the threat? The only way it makes kind of sense is X-frame options. So you kind of put this header, you say deny, and suddenly your page cannot appear in an iframe anywhere. There are other options like saying same origin or allow from, which you can use to kind of give a bit more freedom. And X-frame options is an old header. CSP, content security policy, can do this whole thing better, which we will see in a moment. And why is it still there? It's because CSP in this version 2 is not supported by Internet Explorer. So you might still want to use X-frame options to have some layer of security also for Internet Explorer users. Okay, content security policy. This is kind of big. I mean, this is kind of big, and it is not done yet. The header right now mitigates some clickjacking and cross-site scripting attacks. So it can do what we have seen and do a bit more. And the problem with this header is we will not be able to go into every detail with this one because it is kind of big. So I kind of thought it would be nice to see some real examples how others do it. And here an example from the page content security policy. I mean, if someone is hosting this page, then he knows something about content security policy. So let's look at what kind of a header he did define. So what you see here, the first part are directives, and the second part are sources. So it's kind of directive sources. You kind of, for the contents that can appear on the page, you define the sources which are accepted for them. So here an example, default source known. So you kind of disable everything, every kind of source for every kind of content. This is an idea of the person who created and configured it, and it's a nice one. The content security policy page is a read-only page. So it does not have any forms you can put data in. It's kind of read-only. So what you see here, script source, it kind of allows a certain kind of JavaScripts to be run. Self means self, well, the system that is hosting the page. Then we see Google Analytics, and then we see a digest, and it kind of means that in the HTML there is an inline JavaScript, and inline JavaScripts are in the normal mode prohibited from being executed. And you can kind of allow certain kinds of scripts to run. And if the script is static, you can kind of encode this digest that only this script is allowed to run. So if someone finds a cross-site scripting vulnerability inside of your system, this vulnerability will not be exploitable. Well, it will be harder to exploit because he will not be able to inject JavaScript, because even if he injects the JavaScript, it will not be executed. This is the whole idea behind the script. It kind of raises the bar, so a successful attack on the page will be harder to be done. Style source. So it kind of defines the sources for the CSS styles, then the fonts that are accepted, then the images, and that's it. Nothing more. All the rest is kind of done by this default source none, which kind of disallows all the other things to be downloaded, executed, to run. Another example from Have I Been Pwned page. A nice page. You can check on this page if your password or your digest ever leaked from any of the systems you have been registered at, and you do it by kind of putting your email address in. So kind of a nice page. Go there, check your email, why not? And what you see here is another approach to the header. First of all, it does not turn off everything. It kind of defines that the default source is self and Google. Then the JavaScripts, well, what you see here is self and Google, and there is it's a template, kind of not only one Google's domain, but different. And what you can see here by this unsafe inline, unsafe eval, they kind of turn this inline scripts on. Why they do it? Well, probably they have reasons. Eval is also kind of prohibited from execution unless you turn it on by this unsafe eval. Why someone turned it on, I don't know, but he might have good reasons for doing it. Objects, like the object tag, styles, images, media, like, I don't know, music or movies here known, so they cannot be executed. Fonts, child source. Child source is kind of the opposite of X-frame options. You kind of define which domains can appear on this page in an iframe. And what you see here, some of the domains are allowed to do it. Form action is exactly what X-frame options did. So you kind of define who can frame you. Oh no, this is frame ancestors. Frame ancestors is about who can frame you, and form action is about where the forms on your page can send the data to. And one neat thing, block all mixed content, so all mixed content will not be displayed. So even if a developer of your team makes a mistake, it will kind of be prevented. It will not be exploitable. And the best thing, report URI. I mean, this header, this might cause some problems if it is misconfigured for your users. And you kind of would have no channel to know about it. So this directive, report URI, kind of opens a channel so you get to know what kind of trouble your users run into because you're using this header. So you can want to have others host a page where all the data is collected in one place for you to look into it. You can kind of do it on your server as well. A nice thing. And what you need to know about this header is it must not really be a header. It can, CSP is a bit different than all the other headers. It can be a meta tag in your HTML file as well, and it will work this way. And the next thing you must know, you can kind of turn this tag only in a evaluation mode. So it will not prohibit any sources from being executed, but it will run in this report URI mode. So it kind of will report every kind of problem the browser might face. So it is a nice idea when you think about it, because people who have designed this header, they thought about how it can be implemented. So you can kind of implement it in several phases by turning it on and making it more strict every next release. So you kind of have a release where you test this header, and after seeing that your users do not have problems with this header, you kind of turn it on. And you can kind of test an even stricter header configuration next. So this is a bit of magic you can do. So another example by Gmail. No, I'm just kidding. We will not go through this one. Let's move on. X content type options. The browsers think they are smart. They are not. Sometimes they will kind of try to guess the content type of the sources you are offering, even though you have defined the content types yourself. The browser will try to outsmart you. Why is this? Sometimes the developers do not send the proper content type, so a browser who guesses the content type better will offer a better usability to the users. This was the idea about it. And they kind of try to sniff and guess the things themselves. And the problem is PostScript documents are also JavaScript documents. So you might have a kind of functionality where the attacker uploads a PostScript document, and when it is downloaded, it is treated as JavaScript and executed in a browser. So there are certain kinds of risk involved with this kind of sniffing of the browser. So you want to disable it, and you disable it by exactly this header in this configuration. And if you have Spring Security, then this is a secure default for you. Cross-site scripting protection. There is some kind of cross-site scripting protection implemented in your Chrome browser, in your Internet Explorer browser. And it is on by default. And the problem, first of all, it is a nice thing that such a protection exists, and it kind of usually works well. What it does, it kind of prevents certain kinds of reflected cross-site scripting attack from being executed. And the problem is it kind of prevents the attacks by escaping the payloads. It kind of tries to HTMLize the payloads, and the past have shown that it kind of led to some complicated attack scenarios that wouldn't work otherwise. So what you kind of want to do is to turn this header in a most restrictive form on, that it does not escape the attack vectors, that it cuts off the attack vectors completely. So you kind of do this, and this is a Spring Security default. So if you have Spring Security, you're safe at this point. And there is a header I might as well skip, but I will tell it to you so you know, and so you have seen it at least once. Public key pinning. You usually do not want to touch this one, ever. The problem is it actually does what it says. It pins the certificate digests. And the problem is it's not a problem of setting this header and to configuring it. It's a problem of maintaining it over a longer distance of time. I mean, because your certificates will expire, and if you do not change this header definition by then your users will be cut off from using your system. I mean, how bad is it? I mean, is it something you can do worse than this? For Amazon, if Amazon had used public key pinning and they have forgotten to update the digests, then they would kind of not be able to sell anything because the people would not be able to access their servers. So if you're a developers, if someone comes to you and asks to implement public key pinning header, you say no, and you are perfectly excused. Referrer policy, sometimes our URLs hold some kind of secrets. Like you're on a YouTube page and what you see on this YouTube page contains a URL that is hard to guess. So only the people who have access to this URL can kind of see what you're looking. And the problem is there might be some comment fields below. And if someone puts a link there, then you might kind of click on this link, and the request that will be sent will hold the referrer to the exact link with the secret you're on. So you kind of expose the secret to the server on the other side. You don't want this, usually. Usually, when you do not have secrets, it will not matter, but if you do have secrets, you will kind of want to turn it off, and there are 24 of options you can put. The simplest one is no referrer. Set this, and you're safe. To kind of summarize the headers, there are things you kind of should think about at least once. There are things that are very easy and that you kind of should implement, and there are things, some headers impose greater danger than others. So you might want never to touch this one, but content security policy, although I think it's kind of difficult to implement properly because it's big. And it will not be a one-release approach. It will be a multi-release approach. I think you should go for this one. And HSTS, you should go for this one as well, and the other stuff is green, so do it. Why not? The headers, for them to work, they must be supported by the browsers. So if it makes sense to kind of turn some headers on, go to the Can I Use page and kind of see if the browsers do support the headers. It's important. Okay, let's move on. Systems. Our systems, they do have different kind of layers, different kind of filters that filter out some requests before they reach the system. And they kind of have all the ability to drop the requests if they do not fulfill certain requirements. And one of those layers is authentication. What is authentication about? Authentication is about the user stating who he is and kind of giving a proof of who he is. And the most common approach, I can imagine this would be a kind of approach that the Romans, ancient Romans and ancient Greeks did thousands of years ago, is kind of passwords. Who are you? I'm the soldier of a Roman army. State your password. My password is admin04. And I am kind of authenticated with this one. So the first thing I would like you to know is that there's different kind of authentication. We call them factors. And passwords are only one of them. And we can also authenticate by the things we have, like tokens, by the things we are, like retina scanners, and not really by what we do. This is kind of a philosophical factor. It's a nice topic to speak about with colleagues when drinking beer, if you don't have better topics to speak about. So no, skip the last one. I kind of use this picture because it has Homer on it, so I kind of find it funny. And what you usually do when implementing authentication, you take a list of things you should prove, and you go through the list and validate if your authentication is doing fine. And there are different lists. I would advise you to take OWASP ASVS Application Security Verification Standard. And what you will do is kind of implement the same kind of authentication ancient Romans and ancient Greeks did thousands of years ago. Can you do better? Yes, you can. There are different approaches. I would like to speak about this one. This one is called universal second factor. What does this do? First of all, it's a second factor. So first of all, you need your own password to authenticate on the page. And after you do, you kind of grab your token, put this token into your USB port, and push the button. This is it. So you will be authenticated not only through your password, but also through some hardcore cryptography that will be running behind. And if you think how you can do it on your smartphone, usually those authenticators, sometimes they don't. This one has no near-field connectivity, but some of them have Bluetooth, some of them have NFC, so you can kind of think about using them also for your mobile solutions. And the reason I tell you about this is they are kind of very easy to use for the users, and they are kind of very hard for the attackers to crack. Why? It's a late hour, I'm running out of time, and so we will not go through every single thing on this page. What I want you to know is that there are two flows to be kind of implemented by the developers in the application, so they can run a key registration flow and a key authentication flow, and that the thing the authenticator does, it kind of generates a private and public key, gives the public key away, and it can kind of prove, it can respond to some challenges to kind of prove that you are the one who you claim to be. This is the idea behind it. And as a developer, you will kind of get a library for dealing with the server side. You will kind of get a JavaScript library to get with the deal with a browser side. If you're using Chrome on Firefox, the browsers do support this kind of authentication already. If you're using Internet Explorer, business as usual, what more can I say? You can implement them in your mobile phones. There are some certain tricks. It's not that easy right now. We had a smart guy at our company who did this one, and he kind of told us about all the tricks you need to go through. If you ever want to implement this one, contact me. I will pass this information along. He will be able to help you in this one. Okay, authorization, another layer. Let's skip this one. I was told that if I start to tell about authorization, about CSRF protection, people will start to go out of it, or leave the room. Because it is so common right now that you should actually use this one. Okay, CSRF example. No, let's skip this one as well. I mean, no, one thing for you to take, every kind of request you do to your system that changes something in the system must contain some kind of a secret, usually a CSRF token. Because if they do not contain a secret, then someone can kind of send you a link to a page that will fabricate a request to your system, and because of a same origin policy, your session ID will get attached to this request, so it will kind of be executed, although you didn't want this request to be executed. So this is the whole magic of CSRF. You already know the solution, implement it well. And you might have other layers, but the truth is, after all the layers are passed, then there is the system, and this is the problem, because there are certain sets of threads on this system that you will need to deal with. And I am already running out of time. And this is crucial. I mean, this is what Daniel spoke about yesterday a bit. And what do you do with things that are security relevant, that are critical, and you kind of run out of your time and you still need to deal with it anyway? Well, you shouldn't kind of ignore it. You should kind of enumerate them, put them in the order of the criticality, and kind of speak only about the most critical ones. So this is what I will do. 1 minute left. The most malicious thing that can happen to your server after the request passes all the layers, this is the response to the malicious user input. You must kind of treat the user input as a kind of a smelly trash. Always keep this mindset. This is a kind of a smelly trash, and it needs to be dealt with respectively. So what can you do with this smelly trash? You can. I will name you 4 different layers how you can deal with it. First layer, full abstraction layers protection. I mean, never deal with user input like this, that you kind of try to concatenate and mix different abstraction elements, like, I don't know, putting XML together. Use a library that will put it for you together, and that will kind of try to escape the user input if it's malicious. Next thing, you already know this, queries to the database. Do not try to concatenate the unvalidated user input with your queries to other system. This is terrible. I mean, if some of your developers do this, then it is game over. So you might want to use some specialized templates to deal with it in a way where the template is kind of abstracted from the parameterization. This is the proper approach. Escaping encoding. Usually in the modern frameworks, you do not need to deal with proper escaping of HTML elements you put on your page. I mean, AngularJS can deal with it. If for some reason you are stuck with JSPs, they can't. So you kind of need to escape context sensitively every single page yourself, every single value yourself. And then there is validation and whitelisting. If something matches the exact input you kind of expect, then it is okay. You can continue with a flow, but if it does not, you kind of stop right where you are. This is called whitelisting, and it works. What does not work is blacklisting. It does not work for obvious reasons. There will always be things you have not thought about. 4 things to remember. Okay, last thing I wanted to say, if you want for you as a developer to have a list of things you need to think about when dealing with security, I think this is one single best document that can help you with OWASP Application Security Verification Standard. Take this, understand it, and you will be able to build much safer systems. I'm out of time. Thank you for your time. If you have questions, please come over. Thank you.